welcome to this digital assignment report with IUG and Strømmestiftelsen regarding Mali and our project there together with Strømmestiftelsen. So, without using any more time, we will start with the first part of the presentation about the project and the work that Strømmestiftelsen has started in Mali. And I will give the word to Tore Martin to give us a short presentation regarding the project in Mali. Thank you.
Yeah, thank you very much, Nima, and very delighted to be here with all of you. First of all, thanks a lot to Engineers Without Borders for having invited us and also for the good collaboration we are enjoying. So I look forward to this. I will just give it will just be a 5-minute brief presentation on this plastic recycling pilot that we are doing in Mali. I think you can go to the next slide. Shortly about Strømme Foundation, we are a rights-based development organization. We're working basically always through local and national partner organizations. We have a decentralized structure, meaning that all our staff in each region we're working are national staff. We work very closely with the local and national authorities on everything we do. We don't start on anything without engaging authorities on different levels. We work within the 3 thematic areas: education, strengthen civil society, and job creation. And this project here is related to job creation. I think you can just take the next slide. Yeah. The main components is in the project is it's a melting technique, which is very basic, which has been developed by a local organization based in Ouagadougou called Yambare. We have implemented it in 2 pilot projects in Mali, one in San, which is 450 kilometers northeast of Bamako, and one just in the outskirts of Bamako. Basically, we're training 2 groups of people. It's training of women in the collection of plastic and training of youth in the production of school benches from plastic. We'll also just add that the plastic we are collecting is soft plastic. It's plastic bags. We work with 2 different local partner organizations, and we work with the national waste management authorities. You can compare it to Forurensningstilsynet here in Norway. And then we're collaborating with the Norwegian Geotechnical Institute and again, Engineers Without Borders here in Norway. Good, I can take the next one. The main steps is that we are training savings groups on the collection of plastic. The groups, which are mainly women, they collect and clean the plastic, and it is basically sold to the production unit. The plastic is heated up in a kind of basic heating system and put in forms, and frames are made of steel, which is mounted by the youth groups and then sold to schools. Here in the photo, we see on the left side a woman who has sold the plastic to the youth groups, and then it's settled also directly. Yeah, I think you can go to the next. If you have any questions, just stop as we go along. Here we see to the left the forms where the plastic is put into, and to the right we see the melting pot basically, and it's heated up by gas under the melting pot. Yes, next slide. What we have here, we see a final product. One of the youth which are working on the production site. Approximately 10 youth are working on each of the 2 sites, and there's between 2 and 3, 4 girls/women working on it. We try to have a 50% gender equality, but it's not always that easy. Down to the left, you see the production. We have produced in total of 2021 and 2022, we have collected approximately 30,000 kilos of plastic and produced 1,315 benches. Next slide. We have challenges in the project. It's a pilot project, and we are testing out this new technology in a quite demanding environment and the context. The context in Mali is that it's a country which is marked by insecurity. We cannot travel outside Bamako. Our partners, our national staff, they can travel there. I cannot travel outside because of the security restrictions. So the security is one issue. Secondly, cleaning the plastic is an issue, particularly during the rainy season. There's a lot of mud and sand in it. Access to plastic in certain areas. The women's group have cleaned up all the plastic, which is in one way it's very good because it prevents goats and domestic animals from eating the plastic, which is one of the major problems. A challenge is cleaner production process and ventilation, which the engineers have been working on. I'll come back to that. The drying of school benches is something that takes time, approximately between 1 and 2 months, because we don't want to use the benches before they are completely dry. Then the sales and distribution is a challenge. We are working on establishing a model for selling and marketing. For the time being, we have bought all the benches and put into our own programs, apart from approximately 100 benches that have been purchased by one of the ministries. Hey, that was a little bit too quick. Okay, we're working on future funding model and the development of a business plan. Yes, you can go to the next one. I think the steps forward is to continue improving the production technology with the Engineers Without Borders, and also to improve the sales model. We're trying also to look at the lighter, scalable model, because we see that, I mean, it's working quite well in the sense that they are producing benches. The benches are quite solid, and we want to continue the collaboration with NGA and other relevant actors, and also looking at possible advocacy initiatives towards the authorities on the use of plastic, where we look at Rwanda and Kenya, where plastic bags have basically been forbidden to use, which has had a very positive impact on the environment in these countries. Yes, I think that's about it. I think that was the last slide. Thank you very much. If there's any questions, I'm open. Otherwise, we can just take them as we go along. Good. Yes, no questions? Yeah, then I give the word to you, back to Nima. Thank you.
Thank you, Tor Martin. Well, for those that have been following this project from these previous 2 phases, know that probably that this has been going on for some while, and that's something that you can read more about on our web pages. But for this phase again, Willem, please take over and take us through your work for this past time.
Thank you. All right. I'm doing a presentation on a large screen. Is it visible enough, or is it getting tiny?
Looks very good. I can, as far as I can see.
All right. I'll start with telling a little bit about. Well, the thing was I was going to tell a little bit about the background, but Tor Martin, you told most of it already, so I'm going to skip that part. And also, we have started this project for quite some time ago, and I'll do a quick recap of phase 1 and 2, so that we can follow the progress over time. And so then we're going to go into a summary of phase 3, and finally some recommendations for the next phase. Yeah, so the background I won't go into. I'll just move on to the recap of phase 1. The starting point was a model factory in Burkina Faso. That was an idea from Stifters to establish 2 pilot factories in Mali. And our first assignment was to look at the process as it was in Burkina Faso, and find potential improvements to the production process, and maybe most importantly, improvements to health, safety, environment, and quality So we started out with creating a baseline. The pictures on the bottom here are pictures of the factory in 2019 in Burkina Faso. And you can see how the process was at that time. So Ture Martin showed a few new pictures from Burkina Faso. You can see that there has been, if you remember how those pictures looked, yeah, you can see that there has been quite a little bit of a change and improvements in the overall layout and way of working in the factories. Yeah, we started by describing the process step by step, and also on each step we identified the risks and measures that could be taken to mitigate those risks. One of our very early conclusions in regards of health and safety and environment was that we wanted to look at implementing Lean 5S principles to make sure that things are tidy and equipment is in a fixed place. There are processes for improvement in motion, and we thought that that would help at least to take care of some of the health and safety issues in as a first step. So what we're looking at here is our, let's see if I can put up a pointer here. This is a very high level process description from intake to a warehouse where the desks are stored. And then for each of those points, we have broken it down again. This is, for example, the melting process, melting, molding, and pressing. And then we took up, what are the risks that we can perceive here? What kind of measures can we implement? If possible, we had some cost there as well. And we had some notation of, if this is something that you should have, must have, or could have in place. And then we had a very quick, simple layout description of how to make sure that the flow of work in a factory would follow a line so that you don't cross the line. So that would help in making sure that there's no collisions, there's no danger of tripping when you go into each other's work paths. Phase 2, we built on the recommendations from phase 1, of course. The target was a first iteration of the Lean 5S implementations to set some safety measures in place, to create some materials for working in a Lean 5S way of doing things. We also had some work done in regards of looking at the materials that have been processed while they're being processed and while they are finished being processed, because we got an inkling that maybe the gases were not really that healthy to be exposed to. We also had some doubts about the desk, and we got a first generation desk from Burkina Faso shipped to Norway in 2019 or maybe early 2000. We found out that they were quite smelly, and if you touch them, you got black fingers. So we wanted to make sure that the desks were actually safe to use and that the gases were not a danger to the health. So the result of the work is that we did some training sessions with the team in Mali, and you can see at the bottom the pictures here are showing one of the results that all the equipment is in a safe place, in a fixed place. There's a process in place for cleaning the equipment when you're done at the end of the work time. Process in place for making sure that all the moving parts are greased, etc. And we also did some tests. Here's a test. One of the co-workers in Mali, Nufu, is taking a test on the next generation of desks to find out if there's still residue coming off those. And luckily, the result was very positive. There was no more residues coming from the desks, so the team had improved the process with temperature control in the factories in Mali, so that was no longer a concern. We also had some tests done by Sintef on the gases, and the conclusion there was that the gases in itself are not dangerous, but it could lead to, for example, irritated throats or sore eyes or headaches if you got exposed to it too long time. So one of the recommendations is that the workers would use gas masks, and you can see in the picture that has also been put into place. One other recommendation was that the desk should stand still for some time to make sure that the gases that are being released in the drying time are all gone before they are shipped to the end customer. And we did an experiment on cutting the plastic in smaller pieces because we thought that doing that would give a cleaner process in melting the materials. And that was also confirmed in the test. There was some manual cutting of the plastic bags in one batch, and there was less gas and the materials were more manageable and a better quality. So going into phase 3, here our target was to take a next iteration on the job safety practices, the work descriptions that we created in phase 2. Make sure that there was a process in place for continuous improvement. But we were also going to look into power solutions because at the time there was no electrical power available in the facilities. And we want to find out what could be a good solution for getting that into place. Also because we were thinking at the time that maybe we could create a machine that could help in making the process more gas friendly, if you will. We got also some limitations when we started talking about machines, and that is that we do not want to fully automate the process because one of the purposes of those initiatives in Mali is to create jobs, and there's ample of workforce available. So we don't want to make a process that is following everything lean and automate away all manual work. In addition, we had a limitation in that the solutions that we were going to come up with should be portable, meaning that they can be implemented in all facilities, both the 2 in Mali that were in progress, but also maybe other facilities that are under planning in other countries. What we did is we split the work into 3 work streams, and I'll be addressing those separately. So one work stream working with health, safety, environment, and quality, and the Lean 5S principles. One work stream working with the power solutions, and one work stream working with process machine, where the target is to make sure, to find out a process where we can reduce the gases or maybe even create a process where there are no gases being released at all. We started out with some challenges when we were looking into the health, safety, and quality and environment topic, and that was that the job safety practices that had been created in phase 2 had not been implemented fully, basically because the change in organization and management in the teams in Mali, so that had been lying and waiting for us to pick up again. The Lean 5S principles are followed to a certain degree, but also there we got the notion that it was not followed as intended completely. So we started out by creating a new baseline, finding out what is the status today, what is missing. So we sent out a questionnaire and had a workshop with the team in Mali. And we found out that we needed to do another job on the job safety practices because the process in Mali had been changing since we created them a little bit. So we had to update those. And also we found out we need to have some more focus on fire safety. So the job safety practices, we had another workshop around those, and the team in Mali went through this and updated them. And now we have a first version in place, first iteration in place, where those practices are in a good shape. They describe the processes and the measures that need to be taken to secure safety and health for all the workers. And also what is in place now is that there has been conducted a fire safety review and a fire safety training including a first aid training. In addition, some materials were purchased, fire blankets and fire extinguishers. So the feeling from our side now is that things are in a very good shape. Then there was created a quality manual or a quality system in 2 parts. One document describing what the quality system is and what should be in there. And then together with the team in Mali, we created, the team in Mali, the second part was a template for how a handbook could look practically. Then the team in Mali went to work and filled out all the information in that handbook. And we had a small workshop around that. It was looking very, very good. And we feel now that for this part of the work, the health, safety, environment and quality, we don't have any further recommendations in place for the next phase.
Can I shoot in a comment there, Willem?
Yeah, sure.
Because what I think is that what we have now for them is they have a full HSEQ manual. So we don't really need any further work with them. The thing is that they need to keep it updated, and that's kind of the recommendation we need to give them. As long as they keep it updated and correct and keep filling it out and have all the content they need, then they are on par with basically any any Norwegian company I audit at this point. So it's a good level what they came back with in that manual.
Yeah, it was a very good quality of the work that had been delivered from the team in Mali. The handbook will be part of the final report that will be coming shortly. Right, power. We're working on with a background in 3 different alternatives in prioritized order. We wanted to have the facilities connected to the public power grid. Second priority would be to set up solar power installations, and as a final way out, setting up diesel, petrol or gas-driven generators. We were working based on an assumption that there would be 1 heavy-duty machine. We don't know if that is actually going to happen because I'll get back to that later on. At the time, the thinking was that we would have 1 machine that could do the kneading of the plastic dough mechanically and connected to a ventilation system so that there would be no gases exposed into the working area. So that was a base assumption. Such a machine would consume about 2 to 3 kilowatts of power. That was a starting point. Once again, we had a few limitations here. We won't invest in any solutions that would replace manual work. We have a need for a solution that could drive small appliances and maybe some lights. And we want to have solutions in place that are portable to other facilities as well. So yeah, these 3 solution alternatives connecting to the public grid. The public grid is on par with what we are used to in our part of the world. They can supply 3-phase and 400 volts, which is about the same as we have here in Norway. That is, of course, ample of power to drive a heavy-duty machine, so that was a good news. What was a little bit worrying at the time is that the public grid has been quite unstable, specifically in the rainy season. So we were uncertain if that was the final way to go. Now we found out that the Mali government is investing currently in an upgrade in the power grid. So our assumption is that stability and capacity will improve over time. Connecting the facilities to the power grids in San, it would be quite reasonable. Connecting that to the first possible connection point would cost about 40,000 Norwegian crowns. Montagula is a different story. That facility is located 15 kilometers from the nearest power grid connection point. And the team in Mali found out that the facility needs to carry the costs for connecting that facility to the power grid. And that would end up in a cost of approximately 32 million Norwegian crowns. And of course, that is far too much. That would not be sustainable. Other than that, 1 kilowatt from the power grid would cost about 2 kroner. So that is very inexpensive. Solar power. We got some information from other projects in Engineers Without Borders that gave some inspiration. What we found out there is that in order to drive a heavy-duty machine, we would approximately need 50 square meters of solar power panels installed. That in itself is not a problem. There is enough roof space on the facilities. Such an installation could then generate about 10 kilowatt hours per day. And that again can drive a heavy-duty machine for roughly 3 hours. And that may be a little bit too little time. Estimated cost would be 150,000 Norwegian crowns. If we would only put up a solar installation for small appliances and lights, that would be costing about 40,000 Norwegian crowns. And that's about as much as connecting the SAN facility to the public grid. Yeah, we also found out that there are plenty of suppliers locally available in Mali with a lot of experience of installing those type of solar power installations. So we don't need to have any extra investment in getting a team there to put it up. That can be done locally. Generators, final way, backup plan. Also there, plenty of different types of generators are available to purchase locally in Mali. The pictures on the bottom show generators from 3 kilowatts up to 10 kilowatts. Yeah, with a cost variation between 3,000 Norwegian crowns, 40,000 Norwegian crowns, and further up. So investment costs are not too high. Operational cost, a liter of diesel costs about 12 Norwegian crowns. That would cost then approximately 24 crowns per hour of power supply. So a little bit more expensive than the public grid, but yeah. Recommendations in regards of power. For SAN, it's quite obvious to connect it to the power grid. But also then, in addition, have a backup generator in place in case of power failure, which is still an issue at this point in time. Montagula, our recommendation would be to invest in a 10 kilowatt power generation, a diesel or gas generator, because solar power installation would be more expensive and at the same time only give maybe 3 hours of power to a machine. Finally, process, maybe the most interesting parts of the work that has been done so far in regards of that it is connected directly to the process. We found out in phase 2 that mechanical ventilation is not possible. And at least not in the way the process is set up today. As you have seen in the pictures from before, the melting pots is an open pot where people need to work quite hard with the long oars to get the doughs needed in a manageable state. That would mean that any ventilation system on top of it would have to be elevated from that melting pot about 2 meters. And then we would not be able to create enough draft to get the gases moved away from the work areas. So the workers are using gas masks today, but we still wanted to look at a solution for either reducing the need for gas masks or maybe getting it out of the workplaces altogether. And one of the limitations that we got is that the solutions that we are coming up with should be possible to create in a local workshop in Mali. We had a few working hypotheses, and the one thing is that we think that the temperature is too high. We're quite sure that the temperature is too high in the melting process, which is one of the causes of the creation of excess of gases that are created or released in the melting process. And the second hypothesis is that we can, by isolating the melting pots, have a more what is the word I'm looking for? Even temperature in the melting pot, so that the bottom part of the pot is not getting too hot compared to the top part. So we would have a more even melting process, and also that would help in reducing the gas release. So we started by setting up an assessment on what kind of materials are available in Mali for building equipment. We also plan to set up a workshop in Norway where we can conduct experiments. And then we were going to do some experiments in the melting process to find out what could be created of good solutions. Local materials in the workshop. We got a good overview from the team in Mali on what was available of workshops locally around San and Muntugula. Plenty of workshops, all kinds of tools are available, also a lot of materials that can be used in creating machines. So we don't see any issues there. Then we established a workshop that coincided with the establishment of a new branch of Engineers Without Borders in Vestfold municipality. The workshop is set up in Tunsberg. You see some pictures in the bottom. And that's where we started doing some experiments. We invested in a few minor pieces of equipment at low cost, which Strømmestiftelsen paid for. And then we set in motion a few experiments. So the test design, an isolated melting pot with a lid on top of it, and a small test with only 20 plastic bags, just to get a grip on how the materials are behaving in the melting process. On the right-hand side, a schematic drawing of how that should look. Then on the left-hand side, how it looks in practice. This is the test where a small melting pot was put on top of a gas burner, and temperature measures were done on the top, the middle, on the bottom side of the melting pot, and the plastic bags were put in there with a little bit of weight on top of it, and then it just stood there without any further manual work to get it melted. So the temperatures, the results is that the temperature distribution was very good overall. The plastic was melting evenly without having to be having the need to stir in the plastic. There was still a lot of fumes though, and that were built up under the lid, and that could lead to maybe a high concentration of gas if you would take off the lid, which could potentially lead to a dangerous situation. But yeah, so far we can feel that the test results have been very positive. We believe now that we can create a process where one does not have to work the dough in the melting pot to get a good result. We also believe now that we can create a process with a minimum of fumes so that the workers can melt the plastic without having to use a mask. So the recommendation for a next phase then is to start a new round of experiments focusing solely on the melting process. There is already a design in place now for a lid that can be put on top of the melting pot with a valve in it, so that we can release the gases before we open it. That would mitigate the risk of the potentially dangerous situation. We also wanted to conduct a larger scale experiment to verify that the solution would work with large batches. And in addition, we just got send a batch of materials that come directly from a supplier in Mali, so that we can conduct an experiment with the factual materials that are being used locally in the facilities in Mali. So we can replicate the results. Then finally, recommendation follow-up in phase 4. The main target would be control of the gases. Make sure that we create a process where either we don't produce any gases at all, or have a solution in place where the gases are safely being moved away from the working area. Some ideas that we want to work with, the lid with the valve on top of it is one of them. The second one is to have better temperature control with more fine-grained tuning of how to heat up the materials. The deliverables will be then drawings on equipment, not factual equipment. We think that that should be built locally in Mali, but the drawings on equipment that need to be in place, a process for temperature control, and a proposal for protective clothing that can be used. And I think actually that you, Magnus, already came up with a proposal already in this phase. So that would go out.
Yes, or at least we gave them some pointers in the last workshop, using denim clothes or jeans clothing and leather shoes and so on. Well, technically, keep away from synthetic plastic materials in your clothes, because those tend to both be able to handle less heat and it's more prone to melting in contact with hot plastics.
Right, that is what I had to show on the slideshows. So now I'm curious if there are any comments or suggestions, maybe things I forgot from the team.
I think you must summed up, at least, I think you summed up most of the important parts there, Willem.
Yeah, I also think from our perspective, I think you have concluded quite well, and I think the technical focus is is what we need to focus on, the improvement of the process and the focusing on the process at this stage.
Yeah,
I see.
Concluded with that everything health, safety, and environment is in a large degree now managed by the processes that have been put into place. It works as it is today with the use of gas masks, but we still want to have a focus on that next step then on creating processes or technology that would help to create solutions where we don't have to manage the gases in not too comfortable fashion with the gas mask, because we can all imagine what it would be like to have a gas mask working around a hot melting pot a whole day.
I see we have a question from a chat, Willem.
Yes, we do.
Okay.
The question, Willem, is how severe is the risk of running out of plastic?
I think Ture Martin has a better answer, but my understanding is that there's no risk at all.
No, it's very little, but I mean, for the time being, there's more than enough plastic around, and the teams of plastic pickers are quite mobile, so they can move around. At this stage, it's quite limited. Yeah, but it's a good question.
Do you have, Ture Martin, because I can't remember if we discussed it. Do we have those massive trash piles that you see in other countries as well, in Africa, in Mali as well?
Yeah. Some of the photos that we looked at in the presentation, the previous presentation, there are some massive piles of waste in and around Bamako, wild waste places. And we wanted to attack some of these, but it seemed there's a whole local economy in each of them. So it's really difficult to say, oh, let's clean up the place, let's get everything away, and let's establish like small scale agricultural projects. But it's really different because there's so many. the most vulnerable people living in these areas, they are engaged in sorting the waste and selling it further. So with our principle of doing no harm, we have to be very careful in attacking them. Yeah, I think there was a question from somebody here.
Yes,
yeah, Francisco is having his hand raised.
Your mic, Francisco.
Thank you, Nima. Thank you very much. A very nice presentation and very interesting work was done there. I just have a bit of a question where that I have seen in several countries regarding more regarding the business culture. Safety is more of an attitude than processes. And although you guys, I understand, have implemented processes and perhaps PPA equipment, personal protection, and so on, have you guys considered also indoctrinating the people and help them to change attitude? I originally come from Mexico, and I have worked internationally, mainly in countries, developing countries, where the attitude towards safety is pretty much relaxed and is not taken seriously. So I've seen people that have masks and so on, but they don't use them because it's a bit of a cumbersome, it's hot in the country, etc. So what I wonder what sort of actions you guys have considered for helping people to change their attitude towards safety?
Can I just jump in there right from the bat and say I was surprised by the focus they had on safety in locally. Because every meeting we've had with them, sadly only online, the focus has been on these gases they smell, they don't feel safe. We want to get rid of them. Can we use masks? I mean, the questions about getting masks came from them, not from us. The last time we discussed, they had some minor burns and asked if what can we do about PPE, personal protective equipment. So I am honestly, I was a bit positively surprised regarding their attitudes. And I mean, they implemented. This is not a factory which has. There is not much moving heavy equipment and so on, and they already implemented, like they need visibility vests, which I think maybe is a bit of a step too far, because you're only working in full daylight and you're only working with manual equipment, so there's no chance you won't be seen. But they still implemented that from themselves. So
I think that was a misunderstanding among us, because that was one of the recommendations in the report from phase 2.
Yeah, that might be. Sorry.
And the thinking at the time was that they should have protective vests or skirts or something.
Okay,
and they interpreted it as But I agree with you. There has been a very, very strong focus on safety in the team in Mali, without having to work with changing attitudes. So that has been a very pleasant surprise. Also, there has been some visits from public authorities in Mali when the new factories have been opened, and there has always been a very strong focus on safety.
Thank you very much.
I can only underline that we are, in the Stammer Foundation, security together with the partner is something that has to have a high focus. And as I see my colleagues and also our partners are kind of taking it further. And it's good to hear from you that we get it also confirmed from the engineers that security is has a high focus. So yeah, good.
Thank you. Do we have Marianne has her hand up? Please, Marianne.
Yeah, it's maybe not so much of a question as a comment, but I know you had quite big challenges with not being able to go there, and I just want to say that it's really impressive how far you've come and how creative you've been in sort of finding solutions and testing in Norway and managed to work through all those obstacles. I think that's really, really impressive.
Yeah, I must say that the team in Mali with the first few phases, Nufu as our main contact point, and now Abdurrahman in the last year has been very, very well. They have been available all the time. They have been proactive. They have been working, very, very hard to both to make us happy, but also to make themselves happy. I think
it's great to
it
hear.
has been a very good collaboration.
Yeah, I'll bring that note back to them. I think they will be happy to hear. Yeah.
Another question from, well, I don't know who you are, but it says machine and process.
Yeah, I'm sort of the group lead of machinery and process in Engineers Without Border in Oslo. So I've been listening to what you explained us now. I think share Marianne's point here that you've done a great job, and I think that you have achieved a lot and actually moved forward a lot as well on improving, and in particular on safety, which is incredibly important, I think. And it's also a focus point we have in our group in other projects as well. And you have been touching on the workshop we have in Tønsberg, and I think Rune is online. He's running this workshop in Tønsberg for us right now, and we are also doing a small testing for Senegal project where we are also looking at the exhaust from the when you're warming up the plastic. And of course, we have done a test for Senegal where we use this not gas but electrical fired plate. And actually think maybe Rune, you want to add on to that, but that has improved, I think, the amount of or reduced amount of gases from the heating up. Maybe Rune, you want to add some more to this? It's not online more, are you?
No, maybe you hear me. Yes, we have tested also out with a heating plate, and that was with the pot we have in Tønsberg. That was enough energy to get the heating. That was made with isolation of the pot and at the top. So it's important to let the heat be into the pot. And so the next step both now is to also ventilate out the gases before it's opened. So making test for that might be the next step. And I have got some plastic from Mali. This a small piece of it seems to be a bit thicker and harder than I had thought. But when we have ready for new text, we're also going to test with that plastic.
And I also think that the test we done with electric plate is showing that you get a much better contribution in heat transfer to the plastic, and by that you get sort of less gases and less burning of the plastic, which is positive, I think.
Yes, when we get the heat into the pot, we don't need to use so much heating, so it's not being so hot in the bottom.
So I think that in general, from Engineers Without Border in Norway, we see that sort of improving the safety and environmental issues on the plastic process is important. And I think we need to also and wish to contribute to taking the gases away in a safe way. And I think maybe we could also utilize a small fan to take the gases away from the heating of the plastic.
Yes, so we get the gases out before it's opened.
Yeah. These solutions would require electrical power, and then there are different solutions that need to be implemented for the different facilities. For some, probably we could get that in place with connecting it to the public grid, but that would not be possible for Montagula, meaning that there should be then a generator in place in Montagula to drive that kind of equipment for the melting process.
What is the current heating requirement you have?
Our requirement for the process in Mali, or our testing requirement?
No, I'm thinking about Mali. What type of heat input do you require for melting the amount of plastic you're utilizing?
Currently, they are doing it on look and feel. So I think, if I recall correctly, the temperature would be somewhere between 200 and 220 degrees, but they don't measure it, so it's going on by look and feel.
Yeah, the thing is they have a gas burner, and they just open up the gas bottle, propane bottle, and light the gas, and then I think they just set. I don't think they have a standard setting even. I remember we discussed that. I think that was in the previous phase, Willem, but
yeah.
But just they just open it, and then it heats up, and then they just kind of leave it there. And that's one of the problems as well, and that's where the whole controlling the process of melting comes in. But I think we ended up that we need to have something to give them before we can sort of have them try. So if we can find out if you insulate this container and heat with a low speed, just put it that way, so that it heats up slowly and doesn't overheat, you reduce the gases. But we wanted to sort of have some temperatures and things to give them before having them trying to optimize the process locally.
Yeah, they are also experimenting locally with reducing the amount of plastic from time to time, or increasing or reducing the temperature in the overall process, which has been leading to those desks now, and the third or fourth generation that does not give any residue anymore. So they're doing local experiments as well, but we want to have some more focus on this in the next phase, specifically by isolating the pots, making sure temperature distribution is better, more control on temperature, etc. So that will be an outcome for phase 4.
Thank you, Willem. We also have Magnus has a question. And we are getting out of time. So Magnus, please.
Yeah, great. Thanks. Just a quick one about the business part of it. Like, how far are you from what you think is a sustainable business model around this? I know you mentioned it a bit. I think Tor Martin did. Just a quick comment on that, maybe.
That's a question for Tor Martin, and that gives me the opportunity to jump out because I need to go to the next meeting.
Yeah.
Thank you very much.
Thank you, Willem. Thanks a lot for your presentation.
Bye-bye.
Bye. Very shortly, we are quite far away from, the technical solutions somehow are there. With regards to creating a sustainable financial model, it's something we're working on. And the team is working more on the marketing side now, communication, and because we need to sell the units also. And that is quite demanding also, to sell a new product in this market, which is kind of dominated by state government actors. So it's been worked on, and a colleague of mine and myself are going to Bamako in a week's time to work more on this. So the question is really good, and we have some challenges on it. But I think we will find a solution.
Well, thank you, Tor Martin. Just 1 minute left. If anybody has any last questions? No? Well, with that, I would like to thank both Strømstiftelsen and our EWB team working on this Molly project, and wish you all a pleasant evening. Thank you. Tor Martin.
And I would just say thank you very much to the entire team. We look forward to the next phase. And thanks for a good session. Thanks a lot.
Thank you.